Okay, this little video is just going to be about a very quick review about expanding brackets and collecting like terms. These are very important skills for our algebra, so it's really important that we understand them thoroughly. So if we have a look at the first example, this is an example of just the easiest version of expanding brackets, where we have two separate brackets and they're not multiplying together, so it's two separate terms. All we have to do is multiply the terms in the front of the brackets with what's on the inside of the brackets. So each of the terms at the front is going to multiply on the inside. All we need to remember is if we've got a negative on the outside, we also need to remember to expand that negative. So if we look at the first bracket, you've got 2x multiplying by everything inside the bracket. So you're going to have 2x squared plus 10x. And now we have a look at the second bracket. Remember the negatives expanding out. So negative 3 times x squared and negative 3 times negative 2. So it's going to be positive 6. Then we have a look if there's any common factors. We've got some common factors here. We've got 2 lots of x squared and negative 1 lot of x squared and negative 3 lots of x squared. So if we bring them together, we get left with negative 1 lots of x squared. So I'm just going to write that down. There we go. Now the second example is the example where we have two brackets next to each other. You need to remember that there's an invisible multiplication symbol on the inside there. Now when we've learnt this before, some of us may have called this the FOIL method, or even more simply, multiply everything in the first bracket with everything in the second bracket. So first of all, we look at that 3x. So the 3x is going to multiply by the x, and then the 4. Now the 2 multiplies with the x and with the negative 4. Now anything that's a common term, a like term, we bring it together. So we have negative 12 and positive 2, that's negative 10. Okay, so there we go, that's that example there. These next two examples, examples 3 and 4, are both examples of the same type of thing. They're actually both perfect squares. But one is an example where we have the addition, and one is an example where we have the subtraction. So we'll have a look at the generalized rule in a second, but just to start with, we'll do the full expansion so we can see the pattern. So remember, when we've got a bracket, a square on the bracket, it's actually the brackets multiplying together. Sometimes we might see this sort of solution with a square just put on each individual term. That's not correctly factorized because that's not what the square term means. So let's just continue on with this expansion here. Okay. Everything in the first bracket is going to multiply with everything in the second bracket. So the x times x. Now if we have a look in the middle here, we've got some common terms, and this is where the pattern starts. Those common terms are always going to be the same in a perfect square, so we're always going to end up with 2 lots of that. I'm actually going to add in an extra line of working here. We're always going to end up with 2 lots of that middle term. That's where the general rule is going to come from. Now, very similar with the subtraction, the brackets are just going to multiply together. We do the same expansion. What we're going to end up with is the subtraction instead of the addition on the inside terms there. So we've still got 2 lots of them, but now they're just negative. So we have 8x there. Now 8x is obviously 2 lots of the 4. So we have if we think about that in terms of a rule, if you have an addition, you take the first term and you square it, the second term and you square it, and on the inside we have two lots of the terms multiplying together, just like we had the 3 and the x, and we had the -4 and the x. Same goes for when we have the subtraction. First term squared, second term squared, and then we minus two lots of the terms together. Okay, now the last example we have here is a difference of two squares. This is a very important expansion because it's really important for us with factorizing. It's very important. Oh, I've just made a mistake there. No square on that one, obviously. It's a very important expansion to remember because when you're factorizing, it's a very important one to be able to recognize in order to simplify situations. So we'll just do the full process, first of all, by expanding both of those brackets. So you've got x squared minus 5x plus 5x minus 25. Now what you notice on the middle here, those two middle terms are going to cancel each other out. Now that's always going to happen because you've got an addition and a subtraction. So that, because of the symmetry of the two brackets, that will always happen. And you're just going to get left with the square of the first term minus the square of the second term. So that's the general rule for a difference of two squares. If you see two brackets and they're exactly the same except one bracket has a positive and one bracket has a negative, the general rule for that is take the first term and you square it, and then you take the second term and you square it. I hope that helps with a little bit of a review of expanding brackets. If you need some more help with it, remember guys, dive into your textbook or come and find me. Okay, thanks.